And let me tell you just a little bit about Christopher before he begins. Christopher Williams is a Portland, Oregon native and has loved the coast all of his life. His studies and work in coastal geology have included work on Lake Michigan shoreline in Illinois, the Atlantic coast in Delaware and Maryland, and southern Florida. He's had both teaching and research assistantships throughout graduate school education. He's taught laboratory sessions for physical and historical geology, paleontology, and dinosaurs. His graduate research includes offshore stratigraphy in Delaware using geophysical techniques and cores, and anthropogenic and natural influences on changes to nearshore marine ecosystems in Biscayne Bay, Florida. His work experiences include geologic mapping in southeastern Oregon with the Oregon Department of Geology and Mineral Industries, sedimentology of the coastal bays and coast of Maryland, for the Maryland Geological Survey, teaching biogeology, coastal processes, regional geology of South Florida, earth resources and the environment, and a portion of geology field camp in South Dakota, Wyoming, and Montana for Wheaton College, Illinois. He's presently a professional geologist with the Florida Geological Survey of the Florida Department of Environmental Protection. He works with updating geological mapping in the state, education and outreach, as well as developing new projects related to coastal issues and stratigraphy in Florida.
Okay. This is just to give you a perspective from what I do with the Florida Geological Survey and the Florida Department of Environmental Protection, which is our larger agency that I work for. Our office is in Tallahassee, Florida, and I've worked for the Florida Geological Survey since July of 2008. Lowell mentioned that I work with the geologic mapping, so I was hired under the State Map program, which is a partially federal grant funded through the United States Geological Survey, and that allows us to update and complete geologic mapping throughout the state of Florida. As far as the issue of being a licensed professional geologist, Florida is one of the states that requires licensure for professional geologists. So a combination of education and work experience is needed to qualify to sit for a national examination. And in Florida, once that examination is passed, a license is renewed every 2 years to maintain employment. There are other things I get to do as a part of my job. The picture here you'll see is when I also coordinate our education and outreach programs. But I also develop new research projects for coastal issues and Florida stratigraphy. Stratigraphy just meaning where are the rocks in Florida and what do they look like in 3 dimensions, not just what do we see right at the surface. As far as my work schedule, I actually work a flex schedule with a 40-hour week over 4 days. But then I also have work in the field, which can be between 5 and 8 days in length. 5 is more typical. And field weeks are actually quite long. It's pretty much you're up at sunrise and you're pretty much done at sunset. So winter field days are a little shorter than other ones. As a part of the field work, here's a picture where I'm actually, this is at Elliott Schiller Homosassa Springs State Park. The field work is reconnaissance mapping. We drive and hike various places throughout the state looking for outcrops of rock. These can be in road cuts, ditches, quarries, sinkholes. We can find them from boats along riverbanks and also in places at the coast. In addition, then, I work with our collection of cores and cuttings, which are from all over the state of Florida. And part of what we also then determine is where we have gaps in our present data, which helps us, again, to create a 3-dimensional picture of what's happening with the geology in Florida. And then this also then involves communication with various public and private landholders to gain property access to be able to drill a core. Now, you might ask, what is drilling a core? This is just a picture of a fieldwork site. The drill rig is the vehicle on the left with the taller mast, and then the other vehicle is for support. All of the different things that we need to be able to drill a core are on the other vehicle, and there are numerous tools. I'll show you a close-up here of just the back of one of our drill rigs. And it's a little bit challenging to see, but you can see there are lots of levers and wrenches and a variety of things. It's pretty complex. It's not super complex, but it's also not a simple operation. As far as work on the drill rig, I don't get to do too much of that because we do have people that are more specifically geared toward that as their main job. But it is physically demanding, and safety has to be a huge priority. Essentially what we're trying to do is to cut a cylinder of rock out of the ground, which is under greater and greater pressure the deeper you go. But what these cores and then cuttings, which is when we collect rocks that actually get ground up in the process rather than collecting a solid core, and I'll show you a picture of a core in a moment here. But they help us, again, to create these three-dimensional models of what's happening in the geology of Florida. This is one of my colleagues holding up. This is actually a cylinder of rock taken out of the ground, and it comes up in various size pieces depending on. There's a lot of issues related to the how the rock is behaving as we pull it out of the ground. Anyway, the importance for what we do is not just an academic pursuit. Mineral and groundwater resources are found based upon the geology. Materials that we use for roads, sidewalks, cell phones, computers, windows, and for many Floridians, our drinking water is all based on and has to do with the geology. And also, we don't often think about this, but the food that we eat grows on soil, and that soil is also based upon the geology of the rocks that weathered to make that soil. There are other factors, organic inputs and other things, but the basic framework of the geology is actually quite important. And so geology does matter whether you realize it or not. The next part of the talk is me giving a whole bunch of different aspects to what I do and how I got into geology. So I'm just going to leave you with a pretty picture here for a few moments. This is Hammock Sink up near Tallahassee. I just wanted to encourage you because sometimes the thought is naive that one's career only entails one's major area of study, but that's not the case at all. I use math, I use accounting to track our budget for the state map grant to make sure we have money to pay staff and also for our field expenses. We also work with large digital data sets, so I have to be familiar with geographic information systems, which is a method to visually represent spatial data. You have to be able to follow instructions and protocols. There's just a lot of details to your work that you have to be attentive and alert. And then also when you work at an agency that's continually existed for 105 years, sometimes items get misplaced or forgotten. And so someone has to be able to organize and clean up and rearrange. You get to work with people that are different than you, which is usually great, but sometimes you have conflict, and those have to get resolved. And so because of that, you have to be able to view things from a perspective that isn't your own. So you're using some psychology, tools for relationship, essentially things you've practiced all your life. It is important that you have a solid foundation in your career area, but you also have to have strong character and an ability to work collegially and in community. As far as me getting into geology, I didn't really think of it as a career at first because my eldest brother is also a geologist. But then I took an introductory course in college, and I realized how much I really love understanding natural systems and the detailed, intricate interconnections that go on in the environment. My specialty is coastal geology. I love the dynamic environment where the land and water meet. And so I work with a lot of surficial geological systems. By some definitions, I would be a physical geographer, but I chose geology because I was always asking the deeper question of why a certain landform looks a certain way. Why is one coastline different than another? And physical geography alone deals so much with the surface that it didn't really deal with the deeper, the underground issues that are often the causes of what we see at the surface. At the end of the presentation, there will be a website which can give a lot more information because there are numerous subspecialties in geology. Again, just look for that at the end. As far as career path, I do have a terminal PhD degree, and so I could have chosen a variety of things to do. My two longest jobs have been working for state-based geological surveys in Maryland and now in Florida. I do also love to teach, and so sometimes I actually contemplate returning to an academic position at a college or university. And I've even considered a teaching certificate allowing me to teach earth and physical science at high school level. A lot of where, the interest that I have in all of these things, it really centered around graduate school when I discovered how much I enjoy communicating science and scientific principles to non-scientists. And so one of the reasons that working for the state is beneficial for that is that I get to answer questions that citizens have, and that can be rewarding. As far as a typical day, what I said here is I don't have a typical day. That is both the best and the most challenging part of my job. I have a lot of varied responsibilities. On any given day, I'm a geologist, I'm an accountant, a colleague, an educator, an organizer. I'm constantly striking a balance along the variety of projects that I work on, and I have to continue to make progress on all of those. It can be a struggle to keep that balance, but one thing is I'm rarely, if ever, bored, and it keeps me growing and constantly having to adapt to the situations at hand. To give you a little bit of an idea of a broad scope, if I think just about the state map project, the geologic mapping that I work on, which again is about half of my committed time in my work, several times a month I have items I have to deal with, the budget and balancing and details. Over the first half of the project, I spent about 4 hours a day at a microscope, looking at cores and cuttings, describing the different rocks and identifying formations. People are like, okay, what's a formation? A formation is essentially the basic descriptive unit we use in geology to discuss what is a certain rock and how it is distinguished from the other rocks around it that are not that rock. So really, again, it's just a basic framework that we look at to identify different rocks from one another, and that becomes important in a lot of our modeling of what's happening with the different units, especially those that have great concern for Floridians because of the fact that they contain the aquifers that we tap for much of our drinking water supply, as well as agricultural water supply. I also spend about 1 week out of each month in the field. Again, that's the part where we drive and hike or boat to find rock outcrops. The latter half of the project, once we've gained a lot of our information, is actually a lot of compilation. There's a lot of detail to compiling data, putting all the different pieces together. And once you come back, I see a question, why just 1 week? Just 1 week because there are a lot of details of what you have to take care of in the office. Once you come back, you have samples that you have to describe, catalog. Then you have to be able to prepare, what did we see this time out? Okay, what's our next study area? And again, I mentioned also the cores earlier. So there are things with cores where we find out, okay, something is really complex in the geology in this area. What do our other materials show? And we look at it and it's like, oh, well, we don't have a lot of information there, so maybe we need to get a core. Well, that then involves finding out who owns the different lands, who can we have access to be able to drill a core, etc. So, again, the field work, yes, it's fun, but it's about 25% of the job for probably 8 or 9 months out of the year. But again, just finishing up with the latter part of the project, we have the photographs, all of these other things that we need to compile to be able to put out a publication at the end of an annual cycle. It's a 12-month project for State Map. And then during the course of one project, we actually have to identify a new map area, propose the area, and then hopefully receive funding from the U.S. Geological Survey to continue that work the following year. So currently, we've been mapping in Central Florida, just north of the Tampa area, and then we'll actually be over toward the Daytona Beach area next year. Question, did I have an interest in rocks when I was little? I did a little bit, but to be honest, since I'm a sedimentary geologist and especially coastal geologist, my main interest was really in sand and salt marshes and things like that. So kind of atypical from what most people think of geologists. They think of a rock hammer going and looking at volcanoes and, hard rocks and crystals and other things. I mean, those things are neat, but to be honest, sand and mud are the main stuff I've gotten to look at. Let's see. Lots of questions. I'm going to have to hold off on these for a moment. Is it a job I would recommend for a family man? Yeah, the answer is yes, because, again, it allows me to accomplish work that I enjoy, but also to spend a lot of quality time with my wife other than the times when I am out of town. And I'll speak to that in just a moment also. I mentioned the core repository and where we have all these samples. This is an example of once the rocks come out of the ground. And so there are boxes of cores like this. We have 19,000 samples from around Florida. The problem that we have, and this is part of the interest in my work, is we only know in a lot of detail about 30% of what we have in our collection. We receive materials from well drillers, from water management districts, cores that we collect, and essentially sometimes they're coming in faster, or it's in a project area where someone isn't specifically working, and so we don't always know what's in our collection. So I gave an example. It's like walking into a library where you'll like almost every book, but you haven't read 7 out of every 10 that's there. So I actually have a lot of satisfaction knowing that what I'm discovering, what I'm looking at, people probably haven't described before, or very few of the samples have been in detail. And so I'm writing up primary geologic data and information, not only for my agency, but also their private sector employees that use these materials for their work in Florida. And then I was also asked to speak some to salaries as far as geologists. The American Geosciences Institute is actually one of the websites I'll send you to, which actually gives a lot of important information for geoscience careers as a whole. It is a more rapidly growing field. About 23% increase in jobs is predicted between 2008 and 2018, which is greater than the 10% overall projected job increase. And the range of pay is pretty wide depending on what it is that you're doing. Jobs that working for geologists in state government and museums, the average is around 60,000. Whereas if you're working in finance and insurance or oil and gas resources, the average would be around 130,000. The starting salaries in those same areas would be about 40,000 and 80,000. So again, there's a lot of variety, and I just wanted to let you know this picture that you see now was taken as part of my job. As a coastal geologist, there's not a whole lot better. I wanted to just let you know, though, when you look at salaries and jobs and things, salary isn't everything. How I got into Florida and how I got to Tallahassee, my wife and I chose to seek employment where both of us could enjoy our work. And she teaches at Florida State University, which is also here in Tallahassee. I work 40 hours a week. It usually gives me a lot of time in each day to pursue other things I love, such as hiking, gardening, mentoring, tennis. And I have geology colleagues working in the private sector. The private sector usually does have better salaries than what I'm currently doing, but they also have very typical 50 to 60-hour work weeks. And one of the things that I get to do is I get to work with the primary geology information. And working with the primary geological information, my colleagues say, well, you actually get to do geology. You're not just writing reports. You're not just reviewing permits and site designs. So you have to really consider the overall job satisfaction in the entire package. And then my main advice to you all as students is find and do what you love to do. I always have had a fascination with coastal geology, even before I realized it was geology that I was really looking at. When I was coming out of my undergraduate, all I got told all the time was the jobs are in environmental consulting. I didn't want to do environmental consulting. So I've had the opportunity to work on masters and PhDs with coastal geology focus, and both of my jobs in Maryland and in Florida have really had that same geology focus, and specifically on coastal processes or on rocks of marine origin. And think about it. Maybe for you, doing what you love means being close to home and family. So find what you love to do that grants you that option also. Don't choose a job or a career just because it's where people are saying that jobs are, or just because you think it's going to give you a salary that lets you keep up with the Joneses. To be honest, it's miserable to make good money and then have to drag yourself to work every day because you hate it. There's rarely a day I don't want to come to work.